All right, this video is a review of the basic types of factoring, specifically in the context of quadratics, although we can also use some of the types of factoring with cubics or quartics or quintics, polynomials in general. So the first type of factoring is the one that is going to work in any situation. You're always going to use this type of factoring. And then the other types that I talk about are going to be pretty much quadratic specific. So greatest common factor, which we use GCF, the acronym, as a shorthand rather than say greatest common factor all the time. This is one that we do use always to factor all sorts of different functions, not just quadratics, because it does happen all the time within the context of quadratics, but also within other contexts as well. So the example that we're going to look at is one that is pretty common with quadratics. So this is the type of thing that you would be seeing in the unit that we are looking at now. Here we have x squared plus 5x. So when you look for the greatest common factor, you're going to look for the GCF not only with the coefficients for each term, so the numbers, but also with the variables. So for our coefficients, the x squared actually has a coefficient of 1. Anytime you have a coefficient of 1, you don't actually have to write it. And then we have a coefficient of 5. So between 1 and 5, we don't really have a GCF there. We're not going to write out a 1 because that would be silly. With the variables, we have an x squared and an x, so anytime you have a GCF with the variables, the GCF would be the smaller of the two exponents. So we have an x squared for the first term, and then we have an x to the first power for the second term, and so our GCF would just be x to the first power. So that's what I'm going to take out. And then after that, we write the leftovers. So x squared divided by x is just x, plus 5x divided by x is just 5. Or you can think of it as x squared, you have two x's here and you took 1 out, so you have 1 left over. 5x, you took an x out, so you have a 5 left over. So that's the factored form for the first example. The second type of factoring that we're going to deal with in the context of the quadratic unit is trinomials. So trinomials are quadratics that have 3 terms. So these are going to be written in the form ax squared plus bx plus c. And so the first type of trinomial we're going to look at is one where the a value is 1. So the x squared term is by itself. So for this example, we're going to write 3x squared plus 27x plus 60. And I know I said a equals 1, but I had you write down a 3, and that's because in this context, 3x squared, 27x, 60, we do have a GCF in this problem of the coefficient for each term. So if you look, you can see that each term is divisible by 3, so we're going to start off by taking out that GCF of 3, and then we have x squared plus 27 divided by 3 is 9x, plus 60 divided by 3 is 20. So at this point, now we have a trinomial where the a value is 1. So this is a more simple factoring problem as far as trinomials go. So to factor a trinomial like this, we're going to look for two numbers that multiply to 20 but add to 9. And when I work on a problem like this, I organize my information in an X. You can do that if you want. You don't have to. Some teachers do, some don't. So I'm going to multiply to 20, add to 9. And you might have already thought of the numbers. If you did, you can write them down. I do want to show you a calculator trick. Just so that if we do run into numbers that are bigger than you are comfortable with, which will certainly happen in the process of factoring, that you have a trick up your sleeves where you can do those and not just feel like your hands are tied and you're unable to work on the problem. So if I'm looking for something that multiplies to 20 and I'm not very good at my multiplication tables, I can click the y equals button on my calculator and type 20 divided by x. 20 divided by x is the function in my calculator. And then instead of graphing it, I can hit second graph and look at the table of values. And what this will do on my calculator is it will give me a whole list of pairs of numbers that multiply to 20. 1 times 20, 2 times 10, 4 times 5, 5 times 4. And so what we'll do next is we will look at these pairs and we will find the one that adds together to be 9. So 1 times 20 adds to be 21. 2 times 10 adds to be 12. So you'll notice as I go down the list that I'm getting closer to a sum that would equal 9. I'm going to ignore the third one because that includes a decimal, which is not going to help me here. 4 times 5, that would add to 9. So that's the solution that I'm looking for, is 4 and 5. So, and as you scroll through, you can see that we get to the point where we start to have only decimals, and you know that none of these are really good options. So at this point, I can see those are my two answers. So I have my GCF of 3, and then my factors are x plus 4, x plus 5. And it's really important you do not forget to keep that GCF within your answer because it is part of the answer. All right, the third type of factoring we're going to review is trinomials, where a does not equal 1. So this is where we're going to have a number in front of the x squared that cannot be factored out as a GCF that's going to stick around. So we have 6x squared minus x minus 2. And the method that I use for these, and depending on your teacher, you might have had a few different methods. I use the slide, divide, bottoms up method. And some teachers teach guess and check. Some teachers teach the box method. So there's different ways that have been taught. And you are welcome to use any method that you are comfortable with. So slide, divide, bottoms up. This is the method that I learned early on in my teaching career, and students tended to prefer it, which is why I have exclusively worked with that since then. Okay, so the first step of the slide divide method is to slide. So we can't start with the x and say, oh, let's look for what multiplies to -2 and adds to -1, because that would be excluding the 6. So our first step is to take the 6 and slide it to the -2. So first step is to slide. And so we're looking for two numbers that multiply to -12 but add to -1. So if multiplication was not our strong suit, we would say we're looking for numbers that multiply to -12. And then here's all of our options. All right, so I'll include kind of both sides here. So multiply to -12, but add to -1. So here, if I look at these numbers up here are adding to positives. These numbers down here are adding to negatives. So I know that I'm going to be scrolling down here in my list on the table. So that adds to -11. This adds to -4. This adds to -1. So I can tell that those are the two numbers I'm going to use, 3 and -4. Okay, so now I have x plus 3, x minus 4. Next is going to be the divide step. So what I do next is I take those factors, x plus 3, x minus 4, and I divide by the number that I slid. So I slid a 6, so I'm going to divide by 6. And I have two fractions written down, 3/6 and 4/6. And I'm going to simplify those if I can. So 3 over 6 simplifies to 1/2. 4 over 6 simplifies to 2/3. And then this is the point where I do bottoms up. So I take the 2 and I move it up to the front of the x. I take the 3, I move it up to the front of the x. So I get 2x plus 1 and 3x minus 2. And then that is my final answer for what the factors would be. So if I were to take these two factors and FOIL them out, it would result in this quadratic right up here. All right, the last type of factoring that we're going to review is difference of squares. So for this example, we're going to write down 5x squared minus 80. And before we get started factoring this, I want to write down on our notes a list of some of the perfect squares so that we have them written out in case we need them. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225. I think that's a pretty good list as far as you might deal with perfect squares that are larger than that, but that's going to be most of them. So when we want to recognize if a problem is difference of squares, we're going to be looking for these numbers. We're going to be looking for variables that say squared or something to the 4th or to the 6th. We're looking for even number variables, or maybe even x to the 3rd and x, because it could be, where it needs a GCF to be taken out. And then we're looking for difference. It doesn't say sum of squares, it says difference of squares, so we're looking for a minus sign. So right now, my clue that this is a difference of squares problem is that I can see an x squared and I can see a minus sign. Right now, between the 5 and the 80, the numbers are wrong, but that just could be because of a GCF. And I do know that 5 goes into 80, so it does appear that this is a problem that has a GCF that I could factor out. So I'll go ahead and do that. Take out the 5, that leaves me with x squared minus, and then 80 divided by 5 is 16. So this is a difference of squares problem because 16 is a perfect square. So now I'm going to keep the 5, and I'm going to write 2 sets of parentheses, one with a plus, one with a minus. And my factors are x plus 4, because the square root of x squared is x, the square root of 16 is 4. X plus 4 and x minus 4. So that is the complete factored version of that problem. Now, if you need a reason to believe that that is correct, you can think of x squared minus 16 as x squared plus 0x minus 16, which means that if you were to factor it, you'd be looking for two numbers that multiply to negative 16 but add to 0. And those two numbers would have to be the same. So they'd have to be the same to multiply to something but add to 0, because they'd have to cancel out. So positive 4 and negative 4, they'd have to be a perfect square to be able to do that, positive 4 and negative 4. So that's why we have one number that's a plus, one number that's a minus, and they have to be the same, because they have to 0 out for that middle term to be missing to be able to get x squared minus 16. So this is difference of squares, 1 plus, 1 minus, and it's just the square root of that number. All right, so these are the three different types of factoring we have. We have trinomials, where you have three terms, one, two, three terms. Either the a could be 1 or the a could not be 1, and you have a slide divide problem. We have where the problem is two terms, and it's a difference of squares problem. And then we have GCF, which we really ought to be checking for every single factoring problem that any factoring problem we ever do, we should always check for the GCF.